test is, how we do it is, we first, we do a sieve analysis. So you're going to do this in your practical class. So we do a sieve analysis with our soil, and the remaining soil in the pan, that means the last one is 75 micrometer sieve, and which is passing through that and collected in the pan. We take that soil out, and we are using about 45 grams of this soil, and we mix it with distilled water. So mix the fines collected in the pan with distilled water, mixing using the milkshake machine, so that the normal shaker, for 2 minutes. So we do mix the fine soil with distilled water and pour suspension into 1000 milliliter cylinder, a measuring cylinder like this, and add more distilled water. So we add distilled water till it comes to 1000 milliliter level, and then palm over top and cylinder, then turn upside down for 5 times. So we mix it again, just keep the palm here, and we make it upside down for 5 minutes. Start taking hydrometer reading. So after that, we put the hydrometer here. Hydrometer is something like this. So I think you saw it last time, and it has a scale here. So you put that one here, and in every 30 seconds, you are going to measure the time and the hydrometer reading. So at first 30, when you just keep it, that is 0 time, and you write the reading over here. And then in 30 seconds, you are going to write the second reading. In 60 seconds, you are going to write the next reading. Likewise, in each 30 seconds, you are going to write the hydrometer reading. When it reaches to 4 minutes, we take the hydrometer out. When it reaches the 4 minutes, we take the hydrometer out and we wash it and we put it back and we take the reading. And 8 minutes again, we take the hydrometer out, rinse it and put it back. So after this, we'll do it till 8 minutes, and we record all these readings. Does that make sense?
Yeah, I'll follow now.
Okay, we are going to do it anyway. So there are 2 kinds of hydrometers. One is giving the specific gravity. Your readings will be in grams per milliliter. The second one is giving the reading as grams per liter. So that scale on the hydrometer, it can be grams per milliliter, or the scale can be grams per liter. So depending on the, so I can't remember which one we have in the lab, but you can see it on the scale. And depending on which kind of hydrometer that you use to do the test, the tables that we need to refer, or the figures that we need to refer, will be different. So you need to keep it in mind. You need to check what kind of hydrometer that you have, and you need to refer the right diagrams to find numbers from the diagrams or else from the tables. Okay, now after that, we have all the readings now. We have the hydrometer readings for different time slots. However, there are some corrections to be done. Temperature correction. Temperature correction means when it is 20 degrees Celsius, where there is no correction need to be done. But when the temperature increases or decreases, material can shrink or expand. So we need to do that correction. Hydrometer is calibrated for 20 degrees Celsius. So there is a chart that we can use to find out the temperature correction. So we are going to use it in the question. The next thing is CA, which is dispersion agent correction. That means in some situations we need to add a dispersion agent. So this agent promote the separation of the particles without letting the particles to clog together. It will assist the separation of the particles. So if we add a dispersion agent, we need to correct it. We need to consider that as well in the calculation. The next thing is the meniscus correction. That means, you know, in a bulb, in like if you have something if you put something in water, you can see the water won't stay like flat. There is a meniscus like this. So you need to correct this. So you need to minus this one. Cm is the meniscus correction. So you need to minus this reading. So when you put the hydrometer, the water near the hydrometer is not flat. It is going like this. So that meniscus correction need to be done. So we are minusing it. So is that clear, Shaun? The three kind of errors, corrections that we need to do?
Yep, follow that.
Okay, now let's see how to do the temperature correction. So temperature correction, we measure the temperature. When we do a practical, we measure the temperature all the time. When we are taking the reading, we measure the temperature as well, because with the time, temperature also can change. So as you see here, when the temperature is 20, there is no correction. So this side is for grams per milliliter hydrometer. This side is for grams per liter hydrometer. So, and also you have two temperature scales. So this one is degrees Celsius and this one is Fahrenheit, degrees Fahrenheit. So you need to be very careful when you're taking these readings. Why is that? So for example, if someone says you did the test in 25 degrees Celsius using a grams per liter hydrometer, what is the correction? Can you tell me what is the CT? So 25, am I going along the degree side or Fahrenheit side? That is here, right? Degree side. And am I looking at this side or this side now after? Grams per liter, so I need to look at this side. So the correction will be positive correction, positive 2 point something, 2 point maybe 8 or something. So my TC is 2.8. Does that make sense? In case if our hydrometer is grams per milliliter hydrometer, you are not looking at this side, you are looking at the other side. You are looking at this side. And the correction will be again a positive 0.001 something, 1 and maybe 5, 1 and 2. So that is for this one. Is it clear, Shaun?
Yeah, that's crystal clear.
Okay, this meniscus, I already told you what is the meniscus. So the correction is this is the error. So you need to minus the meniscus error. So this is always minusing. So you are minusing this, but this one, depending on the temperature, when it is going below the 20, you need to minus the error. When it is going above the 20, you need to plus the error. So you need to look at the sign here. Okay, so less than 20, you are minusing. More than 20, you are plusing. Meniscus error always minusing. And the next one. Okay, so these are the other one is what we call that, dispersion agent. So dispersion agent is always you are minusing. Let me check this. Meniscus error. Let me check the notes. Sorry, this one is plus. Yes, meniscus error is plus. This one can be plus or minus, but the dispersion is always minus. You are minusing the dispersion agent error. Okay, so these are the equations that we can use. So if you find the hydrometer reading as X, you need to plus the meniscus error. You need to plus the plus or minus the temperature error, and you are minusing the dispersion agent error. And this will be your corrected reading. So that is your corrected reading. So you need to consider all of these errors, and we adjust the hydrometer reading to get the corrected reading. So can you remember we discussed about the particle size diameter can be calculated using these three factors. Can you remember that in the lecture we discussed it at the very beginning? Yeah, here. So particle size distribution can be calculated by F1 times F2 times F3. So you don't need to calculate F1, F2, F3. There are charts to use. So let's see the charts. Okay, so this chart is for finding the F1. When you find the F1, you have two lines. So if you know the hydrometer reading, corrected hydrometer reading, you can find the F1 value using this one. For example, if the hydrometer reading is 30, you can go all the way up and you can use these two lines to find out the factor. So the two lines are for the first line. This one is up to 4 minutes. So can you remember I told you up to 4 minutes, you are taking readings every 30 seconds. After that, you take the hydrometer out and you clean it and put it back in the cylinder and you are taking readings. So after 4 minutes, you need to refer the second line. So this is after 4 minutes. So depending on the time, you need to select the right graph to find the F1. Does that make sense? Is it clear, Sean?
Yep, after 4 minutes, use that one after, yep.
And also there are two charts for F1. One is for grams per liter and the other one is for grams per milliliter. So depending on what kind of hydrometer that you use, you need to consider which one to use. So the rest is the same. So if your hydrometer is in grams per liter, you are using this one to find that one. If it is grams per milliliter, you are using this chart. Okay, now let's see F2. To find the F2, we are using this chart. You need to know the temperature. We are measuring the temperature. If you know the temperature and if you know the soil particle density, for example, just take the density 2.6 and the temperature as 18, you can find the F2. So this is your F2. In case if your temperature is in between, for example, if you take the temperature at 21.5, what we need to do? We need to interpolate and find the middle value here. So you don't just take a value, you need to do interpolation and you need to find the right value in between. Does that make sense? Are you there, Sean? Nick, are you back?
Yeah, that makes sense. No, I don't think he's back.
Left, I think. Okay, now the last part is finding F3. To find F3, we need to know the time for different times, we have different F3s. So if we know the time, we just find it again. If the time like it is different, we need to do the interpolation to find it. So that's how we find the F1, F2, F3. So after finding that, we multiply the three factors and we can find the D, capital D, particle size. Then we need to find the percentage finder by mass, and we use this equation to find that. And then the K, we can use this equation to find the K. When we do one question, you will understand the whole procedure. Okay, let's do the question. So in the question, okay, so let's move to the question. Okay, so this is your first question in the tutorial. Do you see the tutorial question, Sean? Am I sharing the right one?
Yep, I can see it.
Okay, all right. So now let's see. So let's read the question. So in the question, they are asking us to, what they say, plot the particle size distribution. So we know how to plot the particle size distribution when we do a sieve analysis, and you already have done it in your payment. We are anyway going to do it here as well. So now they are asking us to plot the particle size distribution with the hydrometer readings. So let's see what they have given. From the hydrometer test, so they have given us the readings. So they are saying mass in suspension. So they have taken 45 grams of the soil from the pan at the bottom of the sieve analysis, and the specific unit weight. So GS is given to us. Specific unit weight is given to us in kilonewtons per meter cube. And dispersing agent correction, CA, is given to us. So CA is given to us. Meniscus correction also given to us. Okay, so two corrections are given to us. Now let's see how to do this. So we need to plot a graph. In the graph, in the x-axis, we need to have the particle size, same as your sieve analysis. So this should be particle size, and the y-axis should be percentage passing in sieve analysis. Here we call percentage finer by total mass. So percentage finer by mass. So this is the graph that we are going to plot. So to plot that graph, we need two readings. We need to know the particle size. We need to find this. The particle size is the D, and the percentage find by mass, this one is the rho. So O as P. We are going to find this P and D. So let's see how to find the P and D. D we can find, if we multiply these three, we can find the D. And P, there is an equation. I showed you the equation. There is an equation. We can just refer the equation and find it. So let's see how to do this. So you can see the readings. We have the time. So 0.5 minutes, 1 minute, 2 minutes, 4 minutes, 8 minutes, like that. We have the time. And we have the meniscus correction. So meniscus correction is CM is given to us. Meniscus corrected hydrometer reading. So this is the meniscus corrected hydrometer reading. And the temperature is given to us. Now we need to find the corrected hydrometer reading. So RC, can you remember what we need to do? We need to minus or plus or minus the temperature correction, and we need to minus the dispersion agent correction. Am I right? Is this how we do? Am I right, Sean?
Yep.
Okay, so this one we need to plus the temperature correction. So temperature is 22.5. When it is 20, if the temperature is 20, there is no correction. But if the temperature is less than or higher than 20, there is a correction. So we need to look at the temperature values here. So okay, so let's look at the temperature correction chart. Okay, can you help me to find the right spot, Sean? So the temperature is 22.5. Am I right? First temperature is 22.5 degrees Celsius. So we are looking at the degree Celsius. 22.5, 21, 2, 3, 4, 22.5 is here. Am I right?
Yep. And we're using grams a litre.
Grams per liter. So my reading will be somewhere here. So maybe it is 0.8. Is that 0.8? Okay, we'll write it as 0.8. Okay, so. Okay, so this is 0.8. Next one. Again 0.8, 22.5, 22. It is a bit different now. We need to look at again and we need to find the answer for that. 22. What do you think, Sean? 22 is this. So maybe
0.6 maybe.
0.6, yes, let's say 0.6. So 0.6, 0.6, 21.5, 22.5, this one also 0.8. Just one more thing, it's 21.5. So if you look at this again, 21.5 is somewhere here. Maybe 0.5. Let's take as 0.5. Do you agree?
Yep, I agree.
0.5, 0.5, 0.5, and 0.5. Okay. Meniscus error, sorry, the CA, the dispersion agent error is given to us. So how do we find these? These are the corrections and the corrected value. How do you find the corrected value? I'm going to write it in a different color. So this is the correction. So to find the right value here, what should I do? I take 40 and I add a 0.8 and I minus 4. Am I right? So the reading is 36.2. Am I right? So this is the correction. This is the temperature. I'm sorry. This is the temperature correction. So the answer here should be 36.2. Am I right?
Yep.
And we can do the other things as well. The next one will be 34.0 minus 0.8 plus 4. Plus 0.8 minus 4. What do we get? 34 plus 0.8 minus 4. So that will be 30.8. 30.8. The corrected values are, now I'm writing the corrected values. Then the next one is 32 minus 0.6 plus 4, which is 35.4. Am I right? The next one will be 30 minus 0.6 plus 4. So that is 33.4. Am I right, Sean?
Yep.
Then the next one is 27 minus 0.5 plus 4, 30.5. And then we have 25 minus 0.5 plus 4, which is 28.5. The next one is 23 minus 0.5 plus 4.
Sorry, it's -4.
Yes, sorry.
Those. I've just been doing it on my other screen. Sorry.
-5. Yeah, the previous one as well, right? Yes, they're all wrong. Oh, I deleted everything. Sorry, I did it wrong. 32 plus 0.6 minus 4. Yes, thank you. So this is 28.6. Am I right now, Shaun?
Yep.
Okay. 30
26.6.
plus 0.6 minus 4. 26.6. And we have 27 plus 0.5, sorry, 0.6 minus 4, which is 23.6. Then we have 25 plus 0.5 minus 4, 21.5. And we have 23 plus 0.5 minus 4, 19.5. And then the 21 plus 0.5 minus 4, which is 17.5. And the next one will be 17 minus 4, which is 13. 14 minus 14 plus 0.8 minus 4, 10.8. Is that right, Shaun, now? So these are the corrected values. Is everything right now?
Yeah, that's what I've done.
Okay. Now let's see, we need to find F1. Let's find F1. So we need to remember up to here, we are going to use one line, and after that we are going to use the second line. Okay, so let's look at the graph. So again, we have two graphs, this one and this one. So which one we should select? Grams per liter, this one, isn't it? And in this, first reading is, the hydrometer reading is 36.2. So our reading will be 36.2. So 1, 2, 3, 4. So it's somewhere here. And we are using the first, isn't it? We are using the first line. Why is that? Because it is not 4 minutes yet. So our reading will be this one. If you draw a line, F1 is close to 3.3. Am I right?
Yep.
So this is 3.2, 3.3. So likewise, we can fill all these values, but when we do this one after 4 minutes, up to 4 minutes, so with 4 minutes actually, including 4 minutes, we need to look at the second graph. So we are looking at the second graph. For example, here, for the 4 minutes, the corrected value is 26.6. So our 26.6 will be here. 26.6 will be somewhere here. And we are going all the way up to this one. because it is now the hydrometer readings will be different. So you take this reading considering the second line. That's the only difference after 4 minutes. Is that clear, Shaun?
That makes sense.
Yeah. When we fill everything, after we filled everything, I will give you the answers because it is taking time otherwise. So we are okay with F1. Let's see how to fill the F2. So to fill the F2, we have to refer that table. So this table here. Now let's take the first one. The temperature is 22.5. So you need to find the value in between. And the GS is given to us 2.65. So this one is given to us. So the reading should be in between these two. So do we know how to interpolate and find the answers, Shaun?
Would we just add them together and find them out too?
Yeah, so we interpolate and find the answer so that answer will be in between these two. So in between 1.316 and 1.332, if I take the reading, you try this by yourself. If you have any issues with interpolation, we'll do it again, maybe next class. It is 1.324. So 1.324, it is between this. So it's the middle point. So you add and divide by 2, it should be fine because this is 22.5 is exactly at the middle. So add these two and divide by 2, then you get the answer for the first one. So you can write this answer here, 1.324. 1.324. So we know how to find the F2. Now let's see how to find the F3. To find the F3, you are using the next chart. So time in minutes. So the first one is time. First one's time is 0.5 minutes. And F3 is 14.14. So finding F3 is very easy. So you just refer the table and you are writing it here. So that is 14.14. Now you have these three. 1.324 and 14.14. If you know these three, the next step is just multiplying these three together and you get it's not writing. Okay. Something happened. Okay, sorry. So when you times these three together, you get the D. So you can fill the D column as well. After that, to find the percentage finance. So D, you know now you already. Okay. Okay, so you can find D. D is F1 times F2 times F3. So you can find D. That is one side. This one is known. So you know the x-axis. Then you need to find the y-axis. To find the y-axis, you have an equation. So it's given at the end of the tutorial as well. So in this one, if you look at your lecture notes, you can find it. P is this. So you can just substitute the numbers in the equation and you can find it. Let's do just one. In this case, let's find the first one here. Okay, so to find that one, P is equals to 0.623, that's a constant, divided by MO. MO is given to us 45. So divided by 45 times by RC. RC is what? RC is the corrected value, which is 36.2, and times by GS. GS also known 2.65 divided by GS 2.65 minus 1 times 100%. So your values, when you consider your values, this is a constant because we took the 45 grams, and this one is a constant, this one is a constant. So this one is changing along the, when you go down in a row, this one is changing. So this one 36.2 for the first one, for the second one it is 30.8, for the third one 28.6. Likewise, you put the numbers, where you can do it in Excel easily. So you put it and that value will be your P. So you now know the P, and you know the D, so you can plot the graph. So when you plot the graph will look like this. You can try this in Excel. Your graph will be like this. And we use a log in the X scale. Like in the sieve analysis also, we are using log scale in the x-axis. So we do the same thing here. So we have D in the x-axis and percentage finer in the y-axis. So these are the answers for everything, like the one that we filled. So you can do the questions by yourself, you can do the calculations by yourself, and you can check whether we get the answers. Any question, Sean? Is that clear?
Yeah, that's clear.
Okay, the last part of this is filling this K value. We are going to do it in the practical as well. How to fill the K value is, we are using this equation. To use this equation, you need to know the mass of the soil remaining in the pan, and you divide the total mass we take for the sieve analysis. For example, if we take 500 grams of the soil at the beginning of the sieve analysis, this will be 500. If we measure maybe 50 grams in the pan, the 50 will be this. So we just use those two numbers and we times that by the P here, so that we get a percentage as a whole of the soil. So this percentage is only considering the fines, but this K is the percentage when you consider the whole soil, coarse and fine together. So that's the answer for your first question. It's a long one, but you will be doing this in the practical, but try to do it by yourself. Use the Excel and let me know if you find any difficulty. So you need to remember, up to here for F1, you are using one graph and for the one line, and up to here you are using the second line in the F1 graph. That's the only difference. The rest is okay. All right. Is everything okay? Do you have any issues? Any